Hello guys, we are on 5.2. 5.2 we are given that cos 35 degrees equals to m. Then they say without using a calculator, determine the value of each of the following in terms of m, okay? Then we got the 5.2.1 as cos 215 degrees, okay? We are having it for 2 marks, okay? That is 5.2.1, okay? We are having cos 215 degrees, okay? We are having it for 2 marks, okay? It means here we don't have to stress ourselves, okay? Since we are given a special angle uh, of 35 degrees, we can try to use it, okay? We can try to express 215 degrees in terms of a quadrant and 35 as a special angle, okay? Then let's punch out our calculator and try to get let's try to get one. Let's see, 180 plus 35 degrees, okay? Then it gives us 215 degrees, okay? Then it means here we can expand. We can say equals to, we're going to have a cos into 180 degrees plus 35 degrees, okay? The 180 is for the quadrant, then the 35 degrees stands for special angle in this case, okay? When you add them, they should give you this, okay? Then now we must reduce, okay? 180, 180 degrees plus is in the third quadrant, okay? In the third quadrant is cosine positive or negative. We remember very well that cosine in the third quadrant is negative. Then this reduces to negative cos 35 degrees, okay? It reduces to negative cos 35 degrees, okay? Then we are given that the cos the, the cos 35 degrees is the same as m, okay? Then here we replace it by m. We're going to have negative m, okay? Then we are done with the first one, okay? With the second one, they say we must find sine 20 degrees for 3 marks, okay? With this one, we might find, actually we might need to unpack the given statement, okay? We might need to construct a right angle triangle, okay? That is 5.2.2, okay? Let's see, here we are having a Cartesian plane. This is our Cartesian plane, okay? This is our Cartesian plane. Then we are going to have the arm in the first quadrant. Then here we put our 35 degrees there, okay? Here I'm just trying to actually to construct the right angle triangle, okay? And here I might have the 90 degrees there, okay? I'm trying to construct my right angle triangle there, okay? Then I remember that the cosine by definition, okay? The cosine by definition cos 35 degrees, they give us as m, okay? Cosine by definition, it should be adjacent over the hypotenuse, okay? Then this should be over 1, okay? Then this is our 35 degrees, okay? The adjacent of 35 degrees should be m. The adjacent of 35 degrees is this side, okay? Then here we are having our m, okay? The hypotenuse of 35 degrees is the longest side, there is the arm itself, then we are having it as 1, okay? Then we must look for this side. Obviously, for us to get this side, we must abuse the theorem of Pythagoras, okay? The theorem of Pythagoras, we remember very well that this r squared being equals to solve for that, this is equal to x squared plus y squared, okay? Our r squared is just 1. The x there is the m because the x-axis is this one, okay? Then we're saying m squared like that, okay? Then we are looking for the y, okay? Then here we're going to end up with 1. Then here with m squared plus y squared like that, okay? Then we will have 1 subtracting the m squared equals to y squared. Okay, we transpose this one to the other side. Okay, algebraically we want to deal with the exponent to there. Okay, we must introduce the reciprocal there. Remember, reciprocal is 1 over 2. Okay, then we introduce there, we will solve for that there, 1 over 2. Okay, both sides. Even here we introduce the 1 over 2. Okay, remember 1 over 2 is a square root. Okay, here we are still having our 2 here. Remember, 1 over 2 is a square root, and square root is plus or minus, okay? But in this case, it's just distance, then we don't worry. Then here we're going to have 1 subtracting m squared, okay, of what? Of square root. And this side, we're having 1 subtracting the m square root like that, okay? And again, we are still having another problem. We need to know how much is this angle, okay? We need to know that we can name our angle as theta. We can say this angle here is this theta, okay? Then we're going to say theta plus 35 degrees plus 90 degrees. They should give us what? 180 degrees, okay? The reason is sum of all angles in a triangle, okay? In a triangle, we are having it like that, okay? Then here we just deal with the algebra. Then we're going to have our theta as 180 degrees subtracting the 90 degrees subtracting the 35. Okay, we just transpose this to the other side. Okay, then now we should know how much is our angle. Okay, we are going to have 180 degrees subtracting 90 subtracting the 35, then we get the 55 degrees. Okay, then it means here it is 55. Okay, it means here it is 55 degrees. Okay, so now we can try to answer the question. Okay, now we can try to answer the question. They are saying that we should get the we should get the we should get the sign of 20 degrees. Okay, we are going to try to expand that using our special angles here, the 35 degrees and the 55. Okay, or we are going to try to use both of them, or one of them, okay, with a quadrant or a double angle or a compound. Okay, so in this case, let me try. We are having 55 and 35. Let me try let me try what 55 subtracting the 35. I'm getting the 20. Okay, yeah, let's try this one. Then here we're going to have the sine into 55 degrees subtracting the 35 degrees. Okay, 55 degrees subtracting the 35 degrees, it gives me the 20. Both of them, they are special angles in this question. Okay, then this is a compound angle. I'm going to expand. Okay, remember, with a compound angle for sine, we're going to have the sine of 55 degrees. That is our A, multiplying the cos of 35 degrees. Okay, if here subtraction, even here should be subtraction. Okay, then the sine of 35 degrees multiplying the cos of 55 degrees. Okay, now we are going to substitute. Okay, they say actually we should look for sine 55 degrees. We come here. Okay, this is our our 55 degrees. Okay, sine by definition, it is opposite over hypotenuse. Okay, the opposite of 55, you must travel a distance, then it means is the m. Okay, the hypotenuse is 1, and then here we are going to have m over 1. Okay, for sine 55. Okay, for cos 35, we are given. Okay, we are told that it is m. Okay, sorry, it is m. Then here I'm substituting the m. Okay, then here I'm having the sine 35. Okay, here's 35. Sine by definition is opposite over hypotenuse. Then it means I'm going to have 1 subtracting m squared all of them square root, okay, divided by 1 like that. Okay, then here I'm having the cos 55 degrees. Okay, here's our 55 degrees. By definition, cosines are adjacent. The adjacent of 50 is this one over the hypotenuse, and the hypotenuse this one. It means even here we're having square root of 1 minus m squared over 1. Okay, then here we're going to have 1 minus m squared, all of them square root, okay, divided by 1 like that. Then now it's just the method of the algebra, okay. M divided by 1 is just m, okay. M multiplied by m gives me m squared, okay. Then here square root of 1 minus m squared divided by 1 is just the square root of 1 minus m squared, okay. Then you're going to have square root of this multiplying the square root of that, okay. Algebraically I can write it like this: 1 subtracting the m squared, okay. Then they are 2, we are having 2 of them and they are multiplying, okay. When the bases are the same, then you add the exponent, okay. Then I'm having 2 there, okay. Remember, if you are having 2 here, the square root is 1 over 2. Then 1 over 2 multiplying the 2, you are going to get 1, okay. Then we will remain with m squared into 1 subtracting the m squared like that, okay. The square root, it was taken care of by the 2 there, okay. Then now we do the distribution, okay. M squared negative 1 multiplying 1, there we have negative 1, negative multiplied by negative, there we got positive m squared, okay. Then we'll end up here with m squared plus m squared, we get 2 m squared subtracting 1 there, okay. Then we are done with that one, okay. We are done with this one. We started here by constructing our right angle